Hey everyone, welcome back. I was gonna pop out of the chair, but I hit my head on the table. It wouldn't be good. So it's day two. We're doing Advent of Code. We're doing it in Elm. Let's take a look. For those of you who missed yesterday's video, it's somewhere. I don't know, maybe below. Who knows? But what we're doing is each day in December for 25 days. There's a new Advent of Code puzzle that gets released at adventofcode.com/2023. I've signed in up here with my GitHub account. And what I do is I just start. We're going to look at the problem together for the first time. If you want to pause here, you can solve it yourself. The way that I'm going to be solving the problems is using Elm, which is a programming language that compiles to HTML. So what we're going to be doing is we're going to be writing code on the left. We're going to be seeing it on the right. And I'm just going to walk you through step by step. We're going to be using Elm's pipeline operator to kind of transform our puzzle input piece by piece to the puzzle output. And then hopefully by the end, we'll get the right answer. We'll get 2 stars, and then we can feel nice. So there'll be a link in the description to the solutions to these puzzles, as always. And if you like this template, I'm also going to include this starter template, which all it includes is just, something that turns your code into something you can print on the right side, as well as some dark mode theme stuff with kind of like the monospace font, which is great for making a YouTube video. All right, so let's dive right into it. This is Advent of Code. Let's open up problem 2 and let's figure out what we need to do today. Yesterday's problem, part 1 was really easy and part 2 was a nightmare. So hopefully this will be more chill. All right, day 2, cube conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes that are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get this information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. Reach in the bag, handful of random, show them to you, back in the bag. Okay. You play several games and record the information from each game. That's your puzzle input. So this is our input here. Each game is listed with its ID number, so like the 11 in game 11, followed by a semicolon separated list of subsets of cubes that were revealed, like 3 red, 5 green, 4 blue, etc. For example, the record of a few games might look like this. So game 1, we got 3 blue, 4 red, and then a semicolon, 1 red, 2 green, 6 blue, and then 2 green. So it's saying in game 1, 3 sets of cubes are revealed from the bag, then put back again. The first set is 3 blue cubes and 4 red cubes. The second set is 1 red cube and 2 green cubes, 2 green cubes and 6 blue cubes, and the third set is only 2 green cubes. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. So it's saying game 1, 2, and 5 would have been possible if the bag had been loaded with that configuration, but game 3 would be impossible because you pulled out 20 red cubes on game 3. So we have 20, which is not possible if there's 12 red cubes. If you add up the IDs of the games that would have been possible, you get 8. So if you add up 1, 2, and 5, that's how we're getting 8. So determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs? Okay, so what we're going to be doing is we're going to be taking each of these lines, we're going to be going through, and we're going to be filtering out the games that are valid, and then we're going to use that to determine which IDs we're going to add up. So I think that's straightforward. Let me just take a look at some of these examples to make sure I understand. So game 2. So the game, they just pull out cubes. So even though Here they said they pulled out 20 cubes. They put all the cubes back in the bag each time, right? Put them back in the bag. Reach in the bag, grab a handful of random cubes, show them to you. The thing I want to make sure I understand is if I'm supposed to be adding up 4, 1 to get 5, or if the, game 3, they pull out 20 red cubes, then put the 20 red cubes back. So basically looking for the max, or am I looking for the sum of everything? Elf will reach in the bag. He'll do this a few times per game and then put them back in the bag. Okay, so he puts them back in the bag at the end. So what we're going to be tracking is the maximum number we see before the semicolons. So this is just a big blob of text. Let's copy this in. Our goal is going to be, let's start with the puzzle input, see if we can filter down to games 1, 2, and 5. And if we can, we'll add those up and get our answer here. And then each Advent of Code puzzle, we're going to get our unique puzzle input, and that's going to be the answer that we're going to put in the prompt. So let's get started here. I'm just going to start by pasting this raw text here. And what we're going to see is this is just a giant string, and each line is separated by this new line character. I've already called string.trim, and what that does, we saw in the last video, it just removes any trailing like white space before. So it'll take care of these like new lines before and after that are caused by me hitting enter right there. So I like to keep string.trim in there for the template that I start with. But what we're going to want to do next is we're going to want to use Elm's built-in string.lines function to split each line into its own piece of text that we can kind of loop through. So here we have this, and then we have a comma, and then we have another string. So what I want to do is I want to run code on each of these to try to parse information out of it. So what I'm thinking is we can take this, turn it into a data structure, and then we can just use that that data structure to try to figure out like what's the max red, what's the max green, that kind of thing. So let's, after we do lines, let's do list.filterMap. And filterMap is going to discard invalid strings. Let's say we had a line here that was just chicken. That would be an invalid game. So any lines that aren't valid syntax, we're going to get rid of. So what we're going to do is we're going to say, we'll come back to filter map, but for now we'll say to game info, or we can just call it to game. So something I didn't show in the last video is types in Elm. So types, they're kind of just like shapes that we can make to help describe what we expect to have. So a game as an ID and then a list of what I'm going to call rounds. So round 1 would be this, round 2 would be this, and then round 3 would be this. And then a round would, I'm going to say is a diction. Let's make it a thing red, how many reds you have, how many blues you have, and how many greens you have. So these are our values. And so what we want to do with toGame is we're going to want to take, I'm just going to put it right, I'm going to put it right here. toGame, a bunch of white space. And what we're going to do is we're going to take each line one at a time, and we're going to try to return one of these data structures. And the way we're going to do that is we are going to take our string, and we're just going to split stuff based on colons. So let me show you what that looks like. If I just had the toGame function, taken the line and return it as is, we're going to see there's no change. But what you can do is you can say for each line, I want to split on colon space, for example. And what that'll do is for each line, it's going to split on this. So each line will have the game with the number 1, and then the second part will have our rounds. So we'll kind of split those into 2 strings. So what we can do is you can say case string.split. If we split the line by that colon, if we get, the game with ID, and then we get the round string, then we're going to be able to return, let's just say we return game with ID if it works. And if not, we can return like nothing. Just say just. String, oops, sorry. When you split a list, what you do is you say, I expect there to be a first element, a second element, and then nothing else. So what this code is doing, let's just do a quick format, is this is saying I want to, I'm expecting 2 elements when I split here, and then I expect no more elements after that. So these colon things, this is Elm syntax for like putting items in a list together, kind of like plus plus, but for adding a single item in front of the list. So this is something called pattern matching that you use a lot in Elm. So here, if I have the game ID, what I want to do is I want to just trim the first 5 characters. So here I could say game ID string dot trim left 5, and then what I can do is say string dot to int game with ID. Oh, I think it's drop left, not trim left. Trim was for getting rid of text. But here, what you're seeing is I have the ID for each game. So I'm getting just 1, just 2, just 3, just 4, and just 5. And earlier I was talking about filter map. Filter map is going to just take off the justs. So what this toGame function is doing right now is it's only returning IDs. So we kind of successfully chopped off everything to the right. We put that stuff in a variable called round string. We'll come back to that. And then we took this stuff on the left. We said drop the first 5 characters. And now we're just going to take whatever's remaining. So if this was 50, hopefully we'd see 1, 2, 3, 4, 50, which we do, which is perfect. So this is just the ID. So I'm going to call it a maybe ID because it only works if we're able to find a valid string when we're done kind of chopping things up. So maybe ID is what we're going to return. So this let expression allows me to make local variables, which is great because I can add type annotations too. So if I format this, this will still work, but Elm allows me to add type annotations, which helps me catch bugs when I make typos, or if I accidentally return a value that is a shape I didn't expect. So that's just the IDs, but as you remember, game is going to need IDs and a list of rounds. So we've discarded too much information. So I'm going to use a built-in function called maybe map2. And I'm going to use game, this type alias, is also a constructor for making this type. So with maybe map2, if we give it game as the first argument, we say there's 2 fields that go in a game, ID and rounds. That's why we use 2 instead of 3 or 4 or 5. What we can do is we can say, I'm going to give you a maybe int, and I'm also going to give you a maybe like list of rounds. And so let's just hard code this as like just a empty list for now. If I put these both in a maybe map2, we're going to get an actual game function here. And I think I have my indentation off is what it's complaining about here. So here you'll see that we're getting a little bit closer, but what we want to do is return this full game type. So toGame now takes in a raw string and it gives us maybe a game. And again, that maybe happens in a few scenarios where it couldn't parse the ID or it couldn't parse the rounds. If there's any invalid input, we're just going to throw away that information. But our puzzle shouldn't have anything unless we write our parser incorrectly here. And parser is just a fancy word I'm using to say something that loops through our string and grabs information that we want. So what we're going to do here is we're going to take that round string and we are going to split the round string here with this semicolon space. And once we have that, we'll have a list of these internal segments. So what I'm going to do here is real quick, I'm going to just comment these out so you can see what I'm talking about. The thing I really like about doing this in Elm with these pipelines is I can show you each step of the puzzle as we go. And just by getting rid of these annotations, we won't have any compiler issues with that. All right, maybe rounds, that's going to be a string, split that. We're going to say just maybe rounds here. So what we're going to see here is so far, maybe rounds is, it's going to be a list where each individual element is the thing that we need to parse. So we can go further. Let me just print out the first element, so we're not looking at all this noise. Oops, sorry. I started typing something and I got rid of it. So here, this is just for game one, right? So for game one, what we have is we have a list. We have the second element is our second game. And so we can go further and we can say for each item in the list, I want to split things with comma space. So now we're going to have a list of lists. So we're going to have 3 blue completely separated from 4 red. We're going to have 1 red completely separated from 2 green. And I think this is a great input to go into a 2-round function. So before we had a 2-game, what 2-round is going to do is it's going to take one of these string segments and maybe return a round back. So I'm going to do that for some more space. So this is going to take in a single like list like this. So this is actually a list of strings, right? And it's going to kind of loop through these and then build up this data structure. I'm going to move it here just so we can see it as we're writing our code. But what I want to get at the end is a round. And so if there's anything invalid, maybe we use a maybe. Let's just say this always works. And if there's any invalid strings, we just don't append information here. And I think that will make this just be a maybe, our list map here. So let's try this out. So you can imagine that the input might look like this for this function. So I'm going to just add a little comment here. This is what comes in. And what we want to spit out is a data structure that helps us know how many red, how many blue, and how many green. So if I call 2-round on this, I expect it to equal that when I'm done. So this is kind of what this function should return. I think this is just a... this happens sometimes in Ellie. Sometimes the syntax highlighting gets a little off. So this is going to be our... I guess I'll just call this words for now. So words is really just like each of these strings. I'll just call it strings. How about that? So what we're going to do is we're going to start with a blank round. So we're going to say round with 0 red, 0 blue, and 0 green. We could type it like this, or we could type it like this if we want. Red equals 0. Line 70 and line 2 are equivalent. Elm, every time you make a type alias for a record in Elm, one of these like object looking things, it's going to automatically be a constructor for that thing. So by saying 0, 0, 0, we're saying there's going to be 0 red, 0 blue, 0 green. If I said 0, 2, 0, because blue is the second slot here, it would be the same as saying this. So I'm going to leave it like this because I think that's a little bit easier for folks to understand when they're coming from JavaScript or a similar language. And we're going to use fold L, which we used in the last video. Kind of works like a reduce. And how that works is you're going to take in each like word, each one of these segments one at a time. I'm going to say just string. We're going to take in the round as is and return an updated round if we can parse the information from this. So that's a lot to take in. But what we want to do here is have this be a function that updates the round. So we're going to make a little local function here called update round. Let's just make it its own function down below. Update round. It'll take in a single string. It'll take in the current round and it'll append. It'll like increment blue, increment green, etc. So this is going to be our word. And then what we're going to do is we're going to take in the round and we're going to return the updated round. And so what we said before is if we see blue, we're going to say, all right, take the current round and add 3 to however many blue we have. Take the current round and add 4 to the red position. So the way I want to do that is do another string split. This time we're going to split on spaces. And we're going to say, let's split that word up. And hopefully we're going to have only 2 things. We're going to have the number, which is going to be a string. So I'm going to call that number string. We use that colon again to separate the first element from the second. This will be color name. as the second thing. And then I think with Elm pattern matching, we're going to even be able to do this. So we'll be able to say blue. And then what we can do is we can say, take that round, take the blue. And what I want you to do is take whatever the current value is for blue, and I want you to add that number to it. But because number is a string, we're going to say take that number, string, turn it to an int if you can. And if you can't, don't worry about it. We're just going to pretend it was 0. So this is a lot of code here. But what we're going to do is we're going to format this. And we're going to say, let's do it like this. Say color name. And we're going to make a little let expression for the number, which is actually an integer. And this will allow us to make our code a little bit easier to read. Sorry, I'm going to break this into multiple lines here. Oops. And then this will be the num. So right now this code is always adding a blue. What we're going to do is we're going to say case color name of blue. We'll do this. Sorry, I gave you some more space so you can read that. And we can do the same for red. We have red as the color. We're going to add to a number of red. Green is the color. We're going to add a number of green. And this is all just that parsing logic that we need. And then Elm is really good about catching edge cases. So here it's like, all right, you told me what happens if I have exactly 2 elements, but what should I do if I don't have 2 elements? If it's like an invalid string, we'll just return the round as is. And then the same will be true here. If I compile again, it's going to be like, great, you told me what to happen when the colors are red, blue, or green, but what do you want to happen when it's a different color, like yellow or pink or banana, something that's not even a color? So again, in those situations, we can't logically like update the round. So we're going to leave it as is. And what we get at the end of it is we're going to get, for the first one, for this first game, we're going to say, all right, blue is 3, green is 0, and red is 4. Blue is 6, green is 2, red is 1. Blue is 0, green is 2, red is 0. And so bringing it all together, the end, here, we're going to say at the end of this, we don't want to return just the rounds. We want to return this full game that we had before. And so all I'm going to do is just put it just here. And then hopefully that will give us our full game. So it'll give us the game's ID, which is 1, and then there'll be a rounds field that has all the rounds information that we just built up together. And so I'm going to add these annotations back on because I think they help explain what these values are. Cool. So that handled the hard part, which is parsing the string. So now that we have the string parsed, we can just run logic. Here we're going to have a list of games. So not just the first one, but we've done this because we use list.filter map. We've looped through every single line, and we've automatically transformed all these into data structures that we can say like, hey, like, are the rounds valid for this game? So what we're going to do is we're going to say list.filter is valid game. And all we have to do here is just make a function that doesn't deal with crazy strings. All it deals with is a nice game data structure that has fields that we can work with. And we don't need to deal with all the edge cases of like, what if it was banana? So if this function is getting called, we have a valid game, or we have a parsed game. And then this function is going to say, does it meet the criteria that we want? So we're going to return true if it does, return false if it doesn't. So the criteria, let's take a look, is 12, at most 12 red cubes, at most 13 green cubes, and at most 14 blue cubes. So what we can do, let's just do a quick map. So if all these games passed, we would return true for all of them. What I want to do is be able to say, hey, get the game rounds. And then for each of these game rounds, let me just comment this out. Let's just take the rounds for each game. And let's say we only care about the blue. this would give us, for each game, how many blue were drawn. So for each round, we had 3, next time we had 6, and then because it wasn't specified, we had 0 for that third round. So now that we have this, what we can do is we can say, give me the maximum blue drawn. Sorry, not list. Is it list max or maximum? So here, it's saying for this game, 3 blue was drawn, 6 blue was drawn, and then 0 blue is drawn, but all we care about is that max number. So for this game, the max number is 6. For this game, the max number of blue is 4, right? Because we have 4 blue here, 1 blue here, and 1 blue here. So what we can do is we can see the max blue, and we're just going to say maybe dot with default 0. So if we didn't get a max, let's just assume there was none. We can do this logic for all the colors. So let's do it with max red. We take that game, we just only care about the reds, we find the maximum, and we assume 0 if we didn't find anything. This maybe with default will only happen if there were no rounds in the game, which I don't think will come up, but if it does, that means that none were drawn, so that's okay. Maybe with default it's kind of a dangerous thing if you're not thinking about what that is. So I'm just going to say max red, max blue, max green, just to show you max red, oops. Just gonna format that. So what it's saying here is that the max for each color, red, blue, green, was 4. Red was the max we ever drew. The most blue we ever drew in a round was 6, and the most green we ever drew in a round was 2. We did that twice. And so in order to figure out if it's a valid game, we have to do that last step, which hopefully will give us the valid games that we care about. And that last step is to say, this game is valid if the max red is less than or equal to these numbers that we care about. So 12, 13, and 14. Sorry, so 12, red, green, blue. 12, and the max green is less than or equal to 13, and the max blue is less than or equal to 14. This will return true for all the valid games. So what we're seeing is game 1, 2, and 5 are valid, but these games aren't valid, which matches what we have in our puzzle input. So 1, 2, and 5 were good, but 3 and 4 were invalid. So instead of using list.map, we're going to use list.filter. And so what list.filter is going to do is it's going to discard all the games that don't pass this test. So what we end up with is game 1. We have where's game 2? And then we're going to have game 5. That's a lot of text. All we really care about is the IDs. So 1, 2, and 5, which are our answers. We can throw away the round information. We already used it to do our filtering. And then as one last step, we're going to do list.sum. That gets our answer of 8. And so 8 is the answer that the puzzle was looking for. So what I'm going to do here is I'm going to save this. I'm going to copy this over here. And then I'm going to add this to the side here for the description in the video. So this solution and all this code is going to be available in the description below. And what we're going to do is we're going to test to see if it's right by taking our puzzle input, and we're going to replace this text here. So the answer I get is going to be different than what you might get, but let's see if this is right for my Advent of Code account. We did it. Okay, so that's part 1. So part 2 is going to be a little twist on the puzzle, and we're going to see how good our code is and if we're going to be able to adapt it to the slight tweak that they're going to do to the problem. So let's take a look at part 2. Part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that have been in the bag to make the game possible? So we're going to consider the same example from before. So in game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue cubes. If any color had even 1 fewer cubes, the game would have been impossible. This 426 looks familiar, right? That was something that we had in our intermediate step from before. So before I keep reading, I just want to show you that was the numbers that we had here. Remember we returned 4, what was it, max? We were returning this last time. And then this here is just going to be a, int. I'm just going to comment these out. So that 426 that they're talking about, that's like a subset of the stuff we already did. So I think part 2 might be fast for us. All right, 426. If any color had even one fewer cube, the game would have been impossible. So game 2 had 134. 134. Looks like that's what our code's doing. Game 3 had 30 or 20, 13, and 6. Can't read. 20, 13, 6. And then, yeah, 14, 3, 15, 6, 3, 2. 14, 3, 15, 6, 3, 2. Okay, so far so good with our code. The power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48. In games 2 to 5, it was 12, 15, 60, 630, 36, respectively. If we add up those powers, we get the sum 2286. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets? So hopefully we don't do an integer overflow here. We'll see how big these numbers get. The sum of the power of these sets. So to get these numbers to multiply, we can just return this, I think, as a list and then do list.product. So rather than returning a tuple, do list.product, all these numbers, and that's going to give us a single number. So here we get 48, 12, 15, 60, 630, and 36. 12, 15, 60, 630, and 36, and then 48, of course. And then when you add up those, we get we're adding up the product, so it probably won't be too big. So if we do a list.sum, we get 2286. And that's our answer. So I think that's part 2. I think this code is right. We don't need to worry about IDs anymore. Because we parsed the data in a nice shape, it was easy to modify the code. We didn't have to worry about changing like the string parsing code, or we didn't do it hacky. So I'm going to save this, copy this. I'm going to go back to Notepad here and save that link for later. And what we're going to do is we are going to try it on our puzzle input. So the puzzle input hasn't changed. Let's copy this in, paste this in. And for me, I got 63,981. Let's see if that's right. Perfect. I think that's the shortest part 2 that's ever happened. All right. Well, thanks for hanging out. Once again, in the description of the video, all the solutions are going to be available. I'm going to see you tomorrow. I'll be back for Advent of Code Day 3. We'll see if we can get through a week of this. Maybe I get through the whole thing. Probably not. But it's been a blast. I'll have also links to learning resources for Elm. So the official guide, that package docs tab that I have over here. That I have over here. So if you ever want to like look up what are those string functions, things like that, there'll be a link in the description below, so you can take a look at what's available. Probably should have mentioned that in the beginning if you were following along, but I'll catch you next time. Thanks for hanging out, and yeah, happy Advent of Code.